These are the answers to past paper practice questions on algebraic expressions, and we're doing test 4. So the first question says subtract negative 2m to the power of 3 plus 6m plus 3m squared from 5m minus 6m squared plus 7m to the power of 3. So what it says is subtract this one expression from the other one. So I take this expression of 5m minus 6m squared plus 7m, and I subtract this expression from it. Now there's two methods of doing this, and I'm going to do both of them. The first one is where we simply write them out, where we have this expression and then we subtract the other one from it, and we write the second one in brackets because the negative sign will then play a role there. So this is then plus 3m cubed. Alright, so now we just have this expression to simplify, where we start off by multiplying out the minus. Here we just copy these down. So the minus goes in, this becomes plus 2m cubed minus 6m minus 3m squared. Right, then we just simply add the like terms. So let's start with the highest, 7m to the power of 3 plus 2m to the power of 3, that gives us 9m to the power of 3. Then for the terms that contain m squared, we've got minus 6 minus another 3, so this gives me minus 9m squared. And then finally we have 5m minus 6m, that gives us negative m. Alright, so that was the first method. The second method is to subtract them underneath each other, where we write the terms with the like terms underneath each other. So we'll start with taking this first one, we had to subtract the other one off. So we have 7m cubed, and I'm going to rearrange the term so that the m to the power cubed is first, then minus 6m squared plus 5m, so that when I write them underneath each other and subtract them underneath each other, that the like terms are underneath each other. So we have minus 2m cubed plus 3m squared plus 6m. So this is then subtracting this whole expression from the one above. So if I subtract, my signs change. So if I say 5 minus plus a positive 6, that becomes 5 minus 6. So to make it easier for yourself, you can go through and first just change the signs, maybe in a different color. So this becomes plus, this becomes minus, and this becomes a minus. So then we'll have 5 minus 6, which gives me negative m. Here we have minus 6 minus 3 gives me minus 9m squared, and here we have 7 plus 2, which is positive 9m to the power of 3. Right, so now for question 2. 2.1, in this whole question we simply have to just simplify all these expressions. So first of all, 2.1, we have this bracket, so all we have to do is just multiply out the bracket, and whatever is in front of the bracket we take to all the terms inside the bracket. So we start with, we've got three things we need to keep in mind: the sign, the coefficient, and the variables. First, the sign. So minus and a plus gives me a negative. Then 4 times 2 is 8, and then y to the power of 2 plus y to the power, or times by y to the power of 3. We add the exponents, so that becomes y to the power of 5. And then to the second term, a minus and a minus becomes a plus, and then 4 times 5 is 20, and then y squared times by y gives me y to the power of 3. Alright, for question 2.2, we have two brackets, and in this case we need to use FOIL, where we start by multiplying, or I'd like to think about it just focusing on the first term in the first bracket and then multiply it with both or all the terms in the second bracket, and then I go over to the second term and do the same, multiply it with all of the terms in the second bracket. Alright, so we have 4x times by 4x, that gives me 16x squared. Then 4x times by 3 gives me positive 12x. Then we move over to this 3. 3 times 4x is plus 12x. And then finally 3 times 3 is 9. So add your like terms. The only like terms we have is this two middle terms. So we have 16x squared plus 24x plus 9. Then 2.3. Here we have another one, exactly the same method to follow as in question 2.2. So p times q is pq. Then p times 2 is 2p. Then minus 3 times by q is minus 3q. And then finally, minus 3 times by positive 2 is negative 6. And over here we don't have any like terms, so this is how we leave our answer. Question 2.4. This is a bracket squared. Now what a lot of people do is they would go and say 4m minus n squared, and then they'll just take the square in. This is very wrong, because if I have x squared, it's the same as saying x times by x. So what I'm going to do is I'm going to expand this. Instead of saying 4m minus n squared, I'm going to rewrite it as 4m minus n twice, as we did with these x variables. So 4m minus n. Alright, and now I'm just going to FOIL it out again. So 4 times 4 is 16m squared. Then 4m times by negative n is negative 4mn. Then negative n times by 4m, this gives me also negative 4mn. And finally, negative n times by negative n gives me a positive n squared. And do I have any like terms? I've got these middle two. Now this is just remains 16m squared. Minus 4 minus another 4. That gives me minus 8mn plus n squared. This was 2.4. So now we move over to 2.5. Now over here we've got a few things to take into consideration. We have this square like we've done the previous one, but then we also have this factor over here that we need to multiply in. Now we cannot multiply it in while that square is still there. We first have to square this bracket out, then multiply it in. So we're going to write the 2x there just to keep it there while we work with the other factor. So we've got x plus 3, which I'm going to expand, x plus 3 because that's squared. Then multiplying out my two brackets with FOIL, so 2x is still there. I'm writing this as x squared, where I multiply the first terms, then x times 3 is plus 3x, then 3 times x is plus 3x, and then 3 times 3 is plus 9. And then 2x is still there. Add my like terms, x squared plus 6x plus 9. And then finally I can multiply out this brackets by multiplying the 2x with each and every term. So this becomes 2x to the power of 3 plus, now we have 2 times 6, which is 12x squared, the x times the x, plus 18x. And that is my final answer. Then we move on to question 2.6. So this is division, and what's easier for me is to actually, if I divide a variable or expression with another expression, I like to write them on top of each other. It's just easier that way. So we have 18 a to the power of 3 b squared c all over 6 a to the power of 5 b c to the power of 4. So now I can cancel top and bottom. So with our fractions, we can say 6 can go into itself once and into 18 3 times. Then we've got 3 a's at the top and 5 at the bottom. So what I'm going to do is I'm going to cancel the 3 at the top with 3 at the bottom, which means there's 2 left. Then one of the b's at the bottom with 1 at the top, so there's 1 b left. And then we have 1 c here that we cancel with one of these at the bottom, so we have 3 left. So let's just write what we have left. So this probably would be better to do it with a different color, so that it doesn't look like a mess like mine does. So here we have a 3. So whatever is at the top, must stay at the top. Whatever's at the bottom, what was left at the bottom must stay at the bottom. So here we had a 3 left. All of the A's are gone. There's one B left, and then the C is gone. Then at the bottom, we have this A squared left, and we have C to the power of 3 left. And then that is our final answer. Then for question 2.7, so here we just have another FOIL. We've got A minus 3B and then A plus 3B. So multiplying the A out with both of these terms, we've got A squared A squared plus 3AB. And then these two terms, minus 3AB, and then a plus and a minus gives me a minus 9b squared. Then adding my like terms, this is plus 3 minus 3, so that becomes 0. That means all that's left is a squared minus 9b squared. 2.8. Now at this point, before you don't know how to do, or before factorization you do these questions differently, and after factorization you do them differently. So since I'm assuming you haven't done factorization yet, I'm going to do it the one method. Or actually, let me do both. First, let's do it without factorization. We know that a plus b over c gives us a over c plus b over c. Alright, so this is then, I'm going to break this up like I've broken this one up. So I get 4x cubed over 2x plus 2x squared over 2x minus 8x over 2x. Alright, so now we just cancel out. So 2 goes into itself once and into 4 2 times, and then x cancels with one of the top ones, so that's 2. So I'm just going to rewrite this so long. 2x squared is left there. The 2's cancel out, one of the x's with one of the top ones, so only x is left there. Then 2 goes into itself once, into 8 4 times. Both these x's cancel out. I'm left with negative 4. Alright, so now let's see how we do the same sum but with factorization. This is now for in case you have done factorization already, since you will start it in grade 9. Now we have 4x cubed plus 2x squared minus 8x, and that is over 2x. So now we factorize this top part. We take out a common factor, and the highest common factor is 2, because I can take out 2 from each term. That's the highest value I can take out, or coefficient. And the highest power of x that I can take out is x itself, because I can not take out any more from this last term than x itself, like x squared, for example. Alright, so if I take out 2x as my highest common factor, what remains in the first term? I've taken out 2, so 4 divided by 2 gives me 2, and I've taken out 1x, so there's an x squared left. Moving on to the next one, I've taken out the entire 2, and I've taken out an x here, so there's only 1x left. And then I take out a 2 from 8, gives me 4, so negative 4. I took out the x, so this is all that's left, and then that is over 2x. Now I can see that this can cancel with that, the x's can cancel, and all that remains is 2x squared plus x minus 4, as we have with the previous example. Alright, so now for 2.9, over here we have got a few brackets to multiply out. We can choose which ones we want. I think I'm going to start multiplying out this first. So for the entire sum, I need to keep my minus 3 there until I've multiplied out the second bracket completely. So first, starting with foiling out this one, we have x times x squared gives me x cubed. Then we have x times 9 is plus 9x. Then 3 times x squared is plus 3x squared. Finally, 3 times 9 is plus 27. Alright, now we don't see any like terms over here. So now the next step is to multiply out this bracket. Now, in this case, we do exactly the same with as we've done with a FOIL, but this is now just a slightly more complicated, because we need to multiply this x with each and every one in the second bracket, and there is 4 terms. So x times x cubed is x to the power of 4, then plus 9x squared, then plus 3x to the power of 3, and then plus 27x. Right, and then moving on to the 3, I have negative 3x cubed when I multiplied with the first term. Second term, we've got negative 27x, and then the third term, negative 9x squared, and then finally 27 times by 3, so 27 times by 3, and this gives us 81, so negative 81. Alright, let's see. Now we definitely have some like terms. This is the only term that contains x to the power of 4. Then let's look at terms that contain x to the power of 3. Plus 3 minus 3, so these two are going to cancel out. Then we have plus 9 x squared minus 9x squared. They also cancel each other out. And then we have plus 27 minus 27, which also cancels each other out, and then minus 81, so minus 81. So that is our final answer there. So now for 2.10, here we have, we're going to work now a lot with exponents. So I'm just going to rewrite this entire question, 169 x to the power of 8 times by x to the power of 3 squared over 13 x to the power of 6. Alright, now let's do this factor by factor. Let's just start with this first expression. Now 169, the square root of that, or 13 squared, is equal to 169. So that means if I take the square root of 169, I get 13. Now, and okay, so let's write down our 13. Then x to the power of 8. Now, whenever I take the square root of a base with an exponent, what happens is the exponent's value halves. So to take that out, that just halves and becomes 4. All right, now what is our rules when we multiply these, or when we have this expression to the power to the power, we multiply the exponent. So this becomes x to the power of 6 over 13 x to the power of 6. All right. At this point, we can actually start cancelling out because this is a multiplication sign. So I can say multiply the 13s, cancel out the 13s and cancel out these x to the power of 6. So all that's left then is just this x to the power of 4. Now for 2.11, here we have a lot of multiplication to do, but let's just break it up first, just to get a mental image. So this is one term. So you can multiply that out, and then we've got another term over here, and we've got another term over here. So let's take that one at a time. If I multiply out the x, I get negative 3x to the power of 3 plus x squared plus 2x. All right, that was easy enough. Now in this one, it's easier to rewrite it as minus 3x x minus 3 by placing this just in front. Then I can just multiply this out as we are used to doing. So this is then minus 3x squared plus 9x. All right, minus and a minus becomes a positive. Moving on, we have this two negative, or no, this is a plus 2x squared going into these brackets. It becomes stays 2x squared just multiplied by 1. The plus and the minus becomes a negative 2x cubed. Alright, so now let's add some like terms. Our highest powers are the x to the power of 3, and we have two of those. So minus 3 minus another 2 gives me minus 5x cubed. When I add like terms, they remain exactly the same. So next up we have these squareds. right there, there, and over here. Alright, so here we have plus x squared plus 2x squared, which gives me a positive 3x squared minus 3, so they actually cancel each other out. Then finally we have 2x plus 9x, so that's just plus 11x. And then we have question 3. So this is a question on substitution. The question says if x is minus 2, y 3, and z are half, determine the value of this following expression. So what we need to do is wherever we see x, we need to replace that with minus 2. Same for y and z. Now, when you replace values, always replace them with brackets. So if I have x, instead of x, I've got this minus 2. Then plus 2, now instead of y, I've got 3. So that's squared, plus y. I'm just going to make this square brackets. So y is then replaced with 3 minus 4, and z is a half, and then that's all squared, and this is all over 2, and then in place of 2 is a half. Right, so that looks like one big mess, but if we treat it bit by bit, it's not that complicated. So this minus 2 can come out of the bracket because there's nothing, no power, no multiplication there. Then over here we have to do this square first. So we first have to say 3 squared before we can multiply it with 2. So this becomes plus 2. This 3 squared becomes 9. Alright, then plus, so here this 3 can just come out of the bracket, nothing multiplied there. 4 times a half. Now you can think about it as cancelling out these fractions where 2 cancels with a 4, or you can just think about it as what's the half of 4, so that's 2, so minus 2, and that's all squared. And that's all over. Now once again, half of 2, or 2 times a half, is just 1. Alright, now we need to multiply out these brackets, so we've got minus 2, that becomes 18, and then plus 3 minus 2 is 1, and 1 squared, or well, let's just write that. Alright, and this is all over 1, so I don't have to write that because anything over 1 is just, you don't have to write over 1. Alright, so then final step, minus 2 plus 18, this 1 squared also becomes 1. Alright, so this is then, I'm going to do it in an order that's easiest to add. I can say minus 2 plus 18 and then think of a number line, but you can add, and normally you're taught actually, which is good, to go from left to right, but when I do mental calculations, I like to add in ways that are easier, like rearranging them. But as long as your sign in front of the number goes with the number. So if I say, I'm going to rearrange them and say 18, which is plus 18 plus 1 minus 2. So you see the signs was like tails, they follow them. So then it's easier to say this is 19 minus 2, which is just then going to be 17.